In this video, we discussed the construction of a histogram using the movies that were discussed in class. This data comes from the website boxofficemojo.com and lists all the movies that have made at least $100 million in the United States. The top grossing movie in the United States was Avatar at $760.5 million, and this list goes to the bottom at Die Hard with a Vengeance at a little more than $100 million. We will construct a histogram for this data, which is a graphical way of representing all these numbers without having to look at all these numbers. To begin, we choose the classes. In this case, I have chosen 9 classes, and that follows something called Sturgis's rule of thumb. Sturgis's rule of thumb dictates that the number of classes ought to be approximately equal to natural log n over natural log 2 rounded up to the nearest integer. In our case, we have 506 movies in the list, and so if I take the natural log of 506 divided by the natural log of 2, this is approximately equal to 9, rounded up to the nearest integer. So that means that if I choose to take 8, 9, or 10 classes, something along those lines, then I should be able to produce a pretty decent looking histogram. However, if I take 30 classes, 40 classes, then I will get a histogram that's too choppy. If I only took, say, 3 or 4 classes, then the histogram would be fairly boring because the blocks would be too large. Okay, so now I can start constructing the histogram. We now have classes that are of different widths. The reason we have different widths is that we can just see that there are very, very few movies that have made more than, say, $400 million. And so it makes sense that I have a very wide class at the top end of the scale so that the frequencies that I get are approximately the same size. So from 300 to $800 million, I have 38 movies from Avatar to Twilight Eclipse. So there are 38 movies in that category. From the next category, 250 to $300 million, that takes me from Twilight Saga New Moon to Men in Black at $250.6 million. So from 66 to 39. Now you might think that the way to compute the number of things in that category would be minus 66 minus 39. However, that would be incorrect. When I did this calculation here, 38, I didn't do 38 minus 1, 38 for Twilight Eclipse, and number 1 for Avatar. Because I counted both endpoints, that 38 minus 1 was incorrect, and I had to add 1. So likewise here, I need 66 minus 39 plus 1 to account for the fact that I'm counting both endpoints. That gives me a total of 28. And indeed, if I take 38 plus 28, that is equal to 66, which gives me the rank of this latest movie here, Men in Black. So for the next category, that takes me from Harry Potter, Prisoner of Azkaban, from 67. Sorry. So that would be number 67. And then the top end of the scale would be Superman Returns at 115. So over here I have 115 minus 67 plus 1, and that gives me the frequency for that class. Now to save us some time, I did this ahead of time, and here are the frequencies for all of these 9 classes. The next step is to figure out the relative frequency, in other words, the proportion of movies that are in each of these classes. The way that I do that is to figure out the frequency and divide it by 506. And so that will give me the proportion of movies in that category. Now I could retype 63 divided by 506, 52 divided by 506, and that's what you'd have to do if you have your calculator as opposed to Excel. However, with Excel, if you notice, there's a black corner in this lower right-hand corner, and so, or a little black square in that right-hand corner. And so if I drag down that square, that repeats the calculation for all of these different categories. So for example, this number here would be equal to 28 divided by 506. Okay, now when drawing the histogram, I do not simply use these relative frequencies. Let me show you what the picture looks like if I incorrectly use those relative frequencies. So ordinarily, of course, I ask you to draw these by hand. Here I'm doing this by computer using the program Mathematica. And there would be the incorrectly drawn histogram, this is wrong if you use those relative frequencies as opposed to the density that we'll compute in a minute or two. The reason that this picture is wrong is because this looks deceptively big. When we look at this by eye, we don't think there's the height of the rectangle. We look at this and think that's a big area of a rectangle, and so there must be a lot more movies in this range than there are in any of these thinner rectangles. So this gives a deceptive picture, so this is incorrect, and I don't want to do this because that gives a deceptive picture as to what the relative sizes of these frequency blocks are. So in order to figure out draw the histogram, I need to figure out the density, the heights of those rectangles. The general principle is that the area of the rectangles will equal the relative frequency, the proportion, and of course the area of a rectangle is going to be equal to the length times the width, or the height times the width. The height, the length of the rectangles, we will have the fancy word of density for that. And therefore, if I want to figure out the density of the rectangle, that will be equal to the relative frequency divided by the width of each rectangle. So, for example, the density of the first rectangle will be equal to this relative frequency divided by 10. The density of the next rectangle would be equal to that relative frequency divided by 10. The next density will be equal to this divided by 10. And the 10, of course, comes from the fact that the difference between 120 and 130 is $10 million. Next category would be equal to this relative frequency divided by 20. And then the next relative frequency divided by 25 for this wider rectangle from 150 to $175 million. The next block will go from here divided by 25. Again, this has a width of $25 million. Next block will be this relative frequency divided by 50 for a width of $50 million. The next block will be again the relative frequency divided by 50. And finally, the last block will be the relative frequency here divided by 500 because the width of this block is $500 million. A couple of comments. You'll notice that I divided by, say, 10 or 20 or 25 and not by 10 million, 20 million, or 25 million. I could have chosen to do that. However, that would have added 6 extra zeros for this particular problem. That wouldn't be all that helpful. And so I will choose that my density is per $100 million as opposed, I said that wrong, per $1 million as opposed to per dollar. Also, you'll notice that the sum of these numbers had better be 1. These numbers here had better add to 506, and so these numbers had better add to 1. The numbers here don't particularly add up to anything. It's just so that the areas represent the proportions. So finally, showing the correctly drawn histogram. So that's incorrect. What is correct is the histogram that you see on the screen now. So notice that this rectangle is much, much lower than all of the other rectangles, so that I have a more accurate representation as to how spread out the movies are in this much wider range compared to the much more jammed, crowded rectangle that you see from 100 to $110 million. So that concludes how to make a histogram. Concluding remarks that we start with the number of classes. We choose classes which might be evenly spaced. In this case, it makes sense to have classes that are not evenly spaced. We then compute the frequencies for each class, the proportion for each class, and then divide by the widths to get the density for each class. And because these relative frequencies add up to 1, we know that the area of a histogram, if I add up all the rectangles in the histogram, the sum of those areas will be equal to 1 as well.